Hello everyone, my name is Aaron Pletz, and I'd like to welcome you to Building an E-commerce Website on AstroDB for session number 1, Product Catalog and Pricing. Our goal for today is to kind of take you through this process and hopefully get you started out right if building an e-commerce website is on your to-do list. So some quick housekeeping things. First of all, there's nothing to install. We're going to be working out of a GitHub repository today that's also integrated with Git Pod. And the nice thing about that is Git Pod will fire up as an IDE and basically run everything right in your browser. It's super cool. So that's going to make things a lot easier for following through on the exercises here. And of course, the application and website we're going to build is going to be sitting on top of DataStax AstroDB, which is our version of Cassandra as a service that we support out in the cloud. So our goal for today is to work through this first session in a series on common e-commerce, retail, colloquially known as e-tail type use cases. Each session is going to build on the previous one, and we're going to show how simple it is to build scalable solutions backed by Java, Spring Boot, and ultimately running on DataStax AstroDB. So let's take a look at the architecture that we've got going for today. First of all, we're going to be building a simple UI that's actually included in the repo and everything. So it's a React.js type of user interface built with Tailwind CSS. The service layer is built with Java using the Spring Boot library. And the backend, of course, hits DataStax AstroDB. So be very simple of what we're working toward today. So why AstroDB? Well, AstroDB is a great choice for a backend database for a large-scale e-commerce system. First of all, because there's no operational overhead. It's a database as a service. So we actually handle all of the pain of managing and operating on it so that you don't need to worry about it. AstroDB, like Cassandra, is geographically aware. So that if you are running a large-scale retail operation online over vast geographic regions, you can have your data replicated out to where your customers are. That way your customers with your application aren't making this really long data trip and then really long trip back that's cutting down on latency and wait time. And it actually makes things easier to build it that way. It's not cloud vendor bound. So the cool thing about that is we can build out AstroDB instances on multiple major public clouds. So we build out in Azure, GCP, and of course AWS. And AstroDB also has no-touch scalability, meaning that when you have periods of higher traffic that require more resources, that will be allocated to your cluster automatically, and there's nothing you need to worry about for that. It'll just elastically kind of grow with your application. Okay. So now that we've gone through that, let's actually jump to our Git repository that we're going to work today. We're going to go to step 2 to start with. Step 2 is going to be creating our AstroDB instance. So what we're going to do is, using the link in the description, go to Astra, and it'll ask me to either create an account or log in using my GitHub or Google credentials. So I'll go ahead and sign in with Google. So as this comes up, you can see that I'm logged in. I'm currently on the free tier. You can see that right up here. And actually, you get a certain number of credits every month that you don't have to add any sort of payment type or credit card or anything to get started. So what I'm going to do is go and create a serverless database. Going to name my database Workshop. Now you can really name the database whatever you like. It's not anything that's used anywhere else. The key space name, however, it is important to make sure that for this exercise anyway, that you're naming it eCommerce. All right, that's going to be important to making things work as we go on. All right. So I'll say, well, let's see. We'll stick in a Google Cloud here, and I'm in North America, so I'll pick South Carolina, and I'm in the free tier, so that looks good. We'll create the database. So now you can see that my workshop database is in a pending state, which means it's coming up. So I should get an email saying that it's started to create it. And then once it's active, I'll get another email saying it's ready to go. And that whole process should take about 5 minutes-ish. So while we're waiting on that, let's jump back to our presentation. So the next thing we're going to talk about while we're waiting for our AstroDB database instance to come up is we're going to talk about use cases. So when you're building an e-commerce website, there are many subsystems or components that really go into making an entire site. However, some of those components are, more necessary than others. Some are really nice to haves. So kind of the 4 main components that we're going to go over in this series are going to be obviously a shopping cart, an ordering system, a user profile, and then the product subsystem is what we'll be building today. So as far as the product services go, there are 3 that we're going to work through today. First of all is the product data service, which obviously has all of the details about each of the products. Next is the product category navigation service, because all products are inside of a hierarchy of categories that gets built out that ultimately we can navigate through. And each product, of course, has a price, so we will need a pricing service to handle that as well. So now let's take a quick look at our data models. Before we get too far into that, let me just say that we could dedicate an entire session on Cassandra data modeling if we really wanted to. Trying to keep this as short as I can. So I just have this slide here for some quick tips on building out large-scale Cassandra data models. First of all, think about the queries that you want to support, and think about the data that you're going to pull back in one query. Well, data that's queried together should be stored together. So think about that. Secondly, you're going to want to make sure you're using high cardinality keys. That's something that's very unique, something like a UUID or a time UUID. What you ultimately want is something that has a lot of possible values, because those are going to distribute in your cluster the best. On the other hand, going with something low cardinality, like a Boolean where you only have a true or a false value, that's going to lead to problems down the road. So, when you implement your keys and you're trying to figure out a primary key strategy, more high cardinality keys, the better. Third, if you've used Cassandra for some time, you know that there's an allow filtering directive that essentially lets you run queries either without a where clause or with a where clause that's very liberal on non-indexed fields. That's really not a good idea to do, especially in production. Allow filtering basically says, hey, I'm okay with doing a full table scan on a distributed database, and that's never going to be fast, and it may actually time out. So, pro tip, let's stay away from allow filtering. And then lastly, try to keep things small. Small partitions, small result sets, small column values. The smaller the better. The more you pull back from Cassandra only what you need, the happier you're going to be. So let's think about the queries that we need to support. First of all, we need to be able to query a product by its identifier. That should be simple. We need to be able to query a product's online price. More into that online bit later, but yeah, that's definitely a requirement. And of course, we need to be able to query product categories in a hierarchy. So this is what our physical data model is going to end up looking like. First of all, we have our product navigation or hierarchies here, where we have our categories by parent ID. Each category underneath that is clustered or has a clustering key based on category ID. That way you can have, multiple categories under a parent ID, and you can recursively call or query that table and get a new set of category IDs as you navigate through. Now, of course, each category is going to contain many products. And each of these products are going to have, they'll be keyed on a product ID, but they're going to have things like brand, description, model, maybe some images. And then of course, based on, if you're a brick and mortar type of retail organization as well, you may have multiple prices for each product. And the reason that happens is that, sometimes you have, you'll have different prices for the same product in different stores. The reality is that it just costs more money to get the same product into Manhattan than it does into Sheboygan, Wisconsin. That's just how it goes. So there'll be some differences in cost based on geographic region. Ultimately, too, you'll have a special web price, likely, because you may run promotions or whatever where everything is a certain price just on the web. So that's a distinct possibility too. So we need to be able to have multiple prices per product is essentially what this is saying. So starting out with that pricing table, it's going to be very simple. We're just going to have a product ID. We're going to have an ID for which store it's in, and we're going to have a value where we actually, store what the price is per product. Now, important to note, but the pricing service and pricing table is separate from product. When you look at smaller e-commerce operations or a lot of examples out there on the web on how to do this, they'll have price simply being a property on the product table. And that might work at a small scale, but the reality is when you're running a large scale e-commerce operation and you have a couple of million products, you probably have several hundred or maybe even a couple thousand developers working in your organization. And you're just going to have separate teams for things. So you'll have a team that handles product data. You'll also have a team that handles product pricing, and they'll build out their services separately. The thing is too, is that price data is going to have a different read-write pattern than product data. You'll have prices be updated more frequently, whereas product data is largely static. Speaking of which, we move right to the product table. In this case, we're going to have a product ID, and that's going to be our lone primary key. We're going to have a product group, a name, a brand, a model number, some description categories, a map of specifications, just if there are any extra properties that we want to add per product, maybe some documents. You might have like MSDS sheets, if there are products that are, have like different chemicals in them or whatever. You might have multiple images as well per product. So we have that as a collection as well. The thing is that when you're using a non-Cassandra database for this, balancing that read traffic can sometimes be a challenge. Especially when you get into the architectural differences between databases and how data is distributed. Really going with AstroDB or Apache Cassandra is going to be the best way to kind of serve this out on a large scale. And that's just with the way that the partition keys are hashed, and then it makes for an easy distribution. And essentially that prevents one specific node or set of resources from being worked too hard. And lastly, of course, we have our category table, which we've talked a little bit about with the having a parent ID for the partitioning key, and then category ID for the clustering key. And that's so that we can have multiple categories per parent. And again, as I said, this is designed to be called recursively. Going through a list of different category IDs every time until you finally work your way down far enough that the products list is populated. So now let's go back to our GitHub repo, and we're going to go to steps 3 and 4 inside the README, which will run us through creating our schema and populating our data. So if I look here, you'll notice that in 3A, we have a command of use eCommerce, and then we have 4 tables that are being created. And I'll talk about that last one for a little bit too. But that's essentially what we're going to accomplish right now inside of that 3rd step. So I waited too long, so I was logged out of AstroDB, so I'm going to have to sign in again. You just make sure that I clicked that. Hey, outstanding. So I'm going to click on my workshop database. I'm going to say CQL console. That's where I want to go. Okay, so the first thing I'm going to do is make sure that I'm using the eCommerce key space. So I'll say use eCommerce, and if you have that, we should have that created already, so that might autocomplete. Oh, look at that. Use eCommerce semicolon. Boom. Now you notice this causes my prompt to change to have the key space I'm currently authenticated to listed in the prompt. Next, I'm going to go ahead and create those tables. Simply put, we'll start with the category table. I can just copy and paste that right in. Then I can go to the pricing table and also paste that. Can go to the product table, just doing a copy and a paste. Let's do a describe tables. Now you'll notice I have a category, price, and product table, just like that. And actually, if I say describe key space, you'll see that the actual data definition language for these tables is contained inside the eCommerce key space. All right, so that's all set. Now, remember I mentioned a 4th table? That 4th table is going to be something called featured product groups. As we were putting this this website together, you know, it kind of came about that many websites have like featured products and have random things that show up, you know, so we wanted to, kind of get a smattering of our products and put them on the front of the site. Well, we didn't really have a service that did that other than to like try and query all the products, which, as you know, is a Cassandra anti-pattern. So we definitely don't want to do that. So we created this table just to be able to feature a few products and show them on the front of the site. So let me get that table over here as well. All right, copied and pasted. Now, if I up arrow through my commands here, you're gonna see describe tables. There you go. Now you can see that that featured product groups table is indeed in there. All right, next, if I go back to the Git repo, we're already on step 4, which is populate the data. And again, we have it listed right in here. So all you really need to do is just kind of select it and copy it in there. And the same thing with our price table. There we go. And again with our product table. Oop, I went way too far there. Okay, copy and paste. All right. And then we'll go to the featured product rows, which there are only 4, but that's really all we need. And we'll paste those 4 in there. Okay, now just to make sure that we have that data in there, let's just do a quick select from that last table there. So we'll do a select star from featured product groups. And you can see, hey, we have our 4 rows in there. Outstanding. Let's move on to talking about the service layer. So the first service endpoint that we have is the price service. Now the price service has 3 RESTful endpoints. First of all, it has an endpoint that allows you to retrieve multiple prices for a single product ID. That's what this first one is. So if you, essentially what you're doing with this is you're querying that price table, but not specifying, you know, a store, so you're getting back all of the prices. Here, you're specifying you want a single price back, and you're also giving it a product ID. And the idea here is it's going to default to the web store and assume that you just want to pull that web price back, which again is useful for what we're doing with the website. And finally, we have that last RESTful endpoint, which will pull a single price back for a product ID and a store ID combination. So here's what a simple example of that, if we're using CQL, looks like, where we have our select from price, where product ID equals, and then we have a product code that we've put in there. And that actually pulls back the product ID, the store ID of web, and the value of $14.99. Moving on, we have the category service endpoint, which again has 2 RESTful endpoints that you can hit. We have a way to retrieve multiple categories with a single parent ID, and that's what we're mainly going to call for navigation. And there's also, I'm sure there are some scenarios where you want to look at a specific category ID, and in that case, you can query a single category with both a parent ID and a category ID. So now, you know, we have a little navigation example here. In our database, and in the data set that we just copied and pasted in, our top level parent ID has this UUID that designates that it's the top. It's that FFDAC 25A 0244 4894 BB31 8088 4BC 82AA9. I know that's a mouthful. I don't expect you to remember all that. That's why we're making a point to call it out here. And actually, this is defined as a variable inside of our website itself. So you know, it's not something that you'll have to worry too much about. But anyway, when I query with just that parent ID, I'm going to get back clothing, wall decor, tech accessories, and then cups and mugs. Now you'll notice that each one has a category ID, and the products list underneath each is null. So there aren't any products at this level in the hierarchy, which makes sense because it's the top. So if I go to the next, let's say that we grabbed, let's see here. What was that? Oh, clothing. Yep. So let's say that we grab the category ID for clothing and we make that be the new parent ID. Well, now we come back with hoodies and t-shirts and jackets. Likewise, let's say that we're going to grab that category ID for hoodies and navigate into that next. So now, as you can see, we actually have products showing up, you know, where we have a vintage DataStax 2015 MVP hoodie and then a DataStax black hoodie. And we have some product numbers listed here. So yeah, that's kind of how this works. So you navigate through the different levels, you know, a clicked on category ID becomes the new parent ID. And then you keep following that exercise until you have your products underneath. Specifically, once we get down to individual products, there really only is one endpoint that we're going to worry about, and that's going to be our product endpoint. And essentially, it's very simple. You're retrieving a single product with a single product ID. And simple enough, if we were to go ahead and query, against our product table for a product ID of DSA 1121L, we would pull back this, t-shirt, long sleeve, large t-shirt about, hey, this is given out at the internal summit. Show how proud you are to talk about the world's best multi-region, multi-cloud serverless database. So there we go. That's individually how each of the services work. Okay, now we're actually going to get down to connecting to our database and firing up this website and watching this all work. So now let's go back to the Git repo and down to step 5 of create your token. So if I scroll down to step 5, you'll see that we have some steps here of going in to manage an application, the application tokens for an organization inside DataStax Astra. And we're going to create a role of database administrator. And that's what we're going to, at least for the purposes of this example, connect to the database with. And eventually, we're going to get a token returned here that we're going to want to make sure that we save off locally just for now. All right, so let's walk through that. So I'm going to go back to my dashboard. And if I have a look, here we go. I see generate a token. So I'm going to click that for my workshop database. All right, so I get this screen that comes up. I'm going to select a role of database administrator. Yep, I get all these privileges with it. And I'm going to say generate token. Now, what you end up getting is a client ID, client secret, and an actual token. Now, you will want to, if this is real, I would probably click this download token details and save that locally. But since I'm just using this for the purposes of the example for this workshop, I'm going to really quickly just kind of copy all of this and just store it in a text file for now. Let me just double check the token and make sure that I got the end of that. I certainly did. Okay, great. So now if I go back to the instructions here, so we have the token, we've saved it off locally. Let's set up our application. Somewhere in here, look at this, right here. Scroll down until you see this button that says Open in GitPod. So I'm going to click this button. Oh, and actually, you know what? What I should have done was right-click and say Open in New Tab. There we go, let's do that. And I will say Continue with GitHub. And I'm going to make sure that my account is authorized. And GitPod is working and preparing my workspace here. All right, so GitPod has loaded. It is still working through some things here. All right, and it's done. So if we go and have a look at our instructions, you'll see that we have this little copy command that we're going to run here. And what that's going to do is take our env.example and create just a .env file. So I'm going to copy that. And right here is where I'm going to paste that in. Yep, I'll allow. So this is essentially a Linux terminal right in here. I'm doing a cp.env.example. And you can see that that file is right here. So let's close some of this just to make things a little easier to follow. And I'll even increase the view a little bit here. and let's hit enter. Okay, now as you can see inside my Gitpod IDE, it's created a new file. And if I go in here, you'll see that my AstroDB ID, region, application token, and key space are all kind of, they're all kind of set as placeholders, although that eCommerce key space is there already. So in order to connect successfully, we need to make sure that all of this is filled out. So I'm going to go ahead and grab my Astra token that I saved off, and that is going to go right here. So that's been pasted. Now, if I go back to, where was that? Here we go. If I go back to my dashboard, what you'll see is I can find my database ID. And that is actually one of the next, one of the two remaining items that I need. So if I go back to here, and then, let's just go to Aster. And if I look at my workshop, you'll see I have this database ID and I have an icon where I can copy it. So now I've done that. Let's jump back to Gitpod and we'll paste the database ID in. Next, as I click into my database itself, you'll see that it's going to reveal the region, which you also need to be able to connect. So let's do that. So if I click on Workshop here, you'll notice that my region is US-East 1. So I'll copy that, go back to Gitpod, and I'll paste that in. All right. Now in Gitpod, when you're modifying a file in their IDE in your browser, you don't need to worry about saving. It automatically saves for you. So that should be very, very simple. Next, you can scroll down, and the last thing we really need to do here is source in that .env file. So that is what I'm going to do next. Okay, and now just to make sure that took, I'm going to run the env command to show me all of the environment variables. Then I'm going to pipe that to grep, and I'm going to look for Astra_DB, because that's what all of these environment variable names are prefixed with. And if I hit that, you can see that I have all four of these defined. So we should be in good shape. Okay, and really, then we can jump all the way from step 6 to step 9, which is run the application. And all we really need to do is just enter this, just basically hit the start.shell script, which if you look is right here. And really all that does is, that already does the source env. So really we don't need that step. But essentially this runs the website itself. So let's go ahead and do that. Just like that. And I can hit enter. Now let's watch it run. And you'll see a lot coming back here. Oh, now you notice I have this thing came up that said the pop-up was blocked. So what I'm going to do is, first of all, I'm going to allow pop-ups from this particular URL, which is my unique Gitpod URL, and I'm going to say done. Now, unfortunately, I have to break out of that, and I have to run that again. But the good news is that this should go faster, and it should actually bring up a browser tab showing the website. So let's see what we got here. Oh, there's our tab. Oh, look at that. We have our featured DataStax products. How about that, huh? Specifically too, I can click into, let's go with hoodies, the same example that we did in the presentation. So if I click into hoodies, you'll see that it comes up with two. You know, we've got our MVP hoodie and our DataStax black hoodie, which I'm actually wearing presently. So if I click into this one, you'll see that, hey, we have it. We have 4 sizes. I can go ahead and I'm a large, so I'd click large, and I would add that to cart if the shopping cart was working. It's not right now, but you'll see that too. It's coming back with a price of $35.99. So this is working. Let's see. If I go back, I can look at T-shirts. Oh, we have an image that didn't work out. Hey, here's my Apache Cassandra 3 contributor T-shirt, which I actually hold very dear. Again, I could pick large, and you can see that it's $13.99. If I needed a 2x large, a double extra large, that would be $17.99. So you can tell that I'm pulling back different prices here, which is good. This is all working. So yeah, I suppose one last thing that we could go over here would be to show you where the code is. If you wanted to look at how to do this, the actual Spring Boot code, here, let me increase size a little bit to make it easier to see. And let's do that. And maybe make that terminal window a little smaller too. And we could even quit out of that. We don't need it running at this point. But if I look in the back end directory under source, main, Java, and then go to, first of all, I can have a look at this eCommerce application Java, which really, let me close that, which really is where Spring Boot takes over and runs this thing and sets up like a mini web server to host it. If I go ahead and look at service, you'll see I have my category directory, featured product directory, my price service directory, and my product service directory. If I were to go ahead and look at, let's see here. I think it's price REST controller. You can see this is where the mapping for the RESTful endpoint is set. You can see where it sets that default store ID to web. And it goes ahead and, we'll go ahead and do that select star from price where product ID. So really, if you wanted to, you could follow this down and actually look at things like this price repo, find by product ID. So if I went to the price repository, again, what we're looking at here is just a simple interface that's extending out that Cassandra repository. It's very, very simple. This was actually the first project I did in Spring Boot, and it was good for me to get caught up on with more recent Java, because my Java certification is like 11 years old. But I digress. But anyway, the point is that building things out with Spring Boot is super easy. All right, so now that we've done that, we come to the homework. So for those of you who would like to earn a badge for this exercise here, the homework we have is pretty simple. It's add your own product to the website. You can find details on how to do this in step number 4, actually, in the README. But essentially, make entries for your own product in the product, category, and price tables, and then add an image into the /UI/public/images directory. And if you take a look in that directory, you'll understand the naming convention and how that has to match up with the product ID, and you should be able to figure that out. But anyway, hey, get that added, and then submit a screenshot of your product being displayed on the site, and you will earn a badge. All right. Thank you to those of you who stayed with us, and we'll see you all next time.